This is PreCalc 12, Chapter 8.3. We're going to look at more permutations, this time involving identical objects. So, for example, how many ways can Canada be arranged? Normally, we treat all the A's as different. So we would have C A1, N A2, D A3. This is the same as C A2, N A1, D A3. And that's also equal to C A3, N A2, D A1. In fact, there's 3 factorial ways to arrange A1, A2, A3. So our answer is 6 factorial over 3 factorial, which is 720 over 6, and that's 120 ways. So however we arrange all 6 letters, we have to take into account that it doesn't matter how we arrange the A's, we just need to divide by 6. Here's another example. How many ways can Mississauga be arranged? Well, we have 4 S's. We have 2 I's. And we have 2 A's. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 letters, so there's 11 factorial permutations. But we have to divide by 4 factorial, 2 factorial, and 2 factorial. So we divide it by all the repeats, and we get 4, 1, 5, 8, 0, 0 ways. Okay, our next example might look a little funny, but we just treat the digits as permutations. So how many ways can 1, 2, 2, 2, 5, 6, 6 be arranged? Well, we have 7 digits. We have 3 2's, and we have 2 6's. So this is simply 7 factorial divided by the repeats. So we have 3 2's, so that's 3 factorial, and we have 2 6's, that's 2 factorial. So this is 5040 divided by 6 and divided by 2. So that's 420 ways. Remember, for most calculators, you don't want to enter this as 5040 divided by 6 times 2. That's incorrect. You need to do 5040 divided by 6 divided by 2. 2 is in the denominator. If you use BEDMAS, this would be 5040 divided by 6, and then you take that result and multiply by 2. It's quite different than dividing that result by 2. And another example, how many ways can 444, 444 be arranged? Well, there's 6 digits. This is really easy. And there's also 6 4's. So this is 6 factorial over 6 factorial, and you don't need your calculator because this is identical. They cancel out and you get 1. Let's look at a slightly harder problem. How many ways can Seabiscuit be arranged keeping the vowels together? Okay, we have 5 vowels. We have 5 consonants. So, if we treat the 5 vowels as a letter, we would have 6 letters. Because the vowels have to be all kept together. In essence, we have S, B, S, C, T, and we'll do this in a different color, V as the vowels. So we have 6 factorial ways to permute this. And we divide by 2 factorial. Because we have two s's. Now, using the fundamental counting principle, we need to arrange the vowels. There's 5 factorial ways to do that. But we have 2 i's. So we need to divide this by 2 factorial. So we have 720 times 120, and we're dividing by 4, 2 times 2. And this is 21600 ways. And again, here's another hard problem. It's a backwards problem. And you have to do some reasoning. Okay, a word contains 5 letters and has 20 arrangements. Just write down what you know first. We have 5 letters. So that's 5 factorial. And we're dividing by x. And we know this is going to equal 20. Okay, now we can just move forward and solve for x. X is equal to 5 factorial is 120 divided by 20. This equals 6. Now, how can we get 6? 6 is 3 times 2 times 1, so that's 3 factorial. There is no other way to factorize this into factorials. We can't do 3 times 2 factorial because whatever we put in the denominator has to be a factorial. So basically we have 1 letter repeated 3 times. So what word has 3 different letters with 1 letter repeating 3 times? Here's one. It's not the only one. Geese. So if we had a problem where x is equal to 24, there is an option here. So this could be just 4 factorial, which means we'd have 1 letter repeated 4 times. Another way to arrange 24 is 3 factorial, which is 6, times 2 factorial, times 2 factorial. So this means we have 1 letter repeated 3 times, another letter repeated 2 times, and another letter repeated 2 times. So this is an ambiguous case. You can have multiple solutions. But if x equals 6 or 12, they are not ambiguous. So 6 is just simply 3 factorial. I'll let you work on 12 by yourself. So the key here is don't just use formulas. You need to take time to consider if you're just using fundamental counting principle, arrangements, or arrangements of arrangements, or arrangements with duplicate objects. And that completes this lesson.